The Big Bang, an event that occurred around 13.8 billion years ago, marks the inception of our universe. It began as an infinitely dense point, often referred to as a singularity, and expanded rapidly. This expansion took place in an incredibly hot and dense environment, where quarks, electrons, and other fundamental particles emerged from the primordial energy. Within the first few moments, the universe cooled down, allowing quarks to combine into protons and neutrons, forming the building blocks of atomic matter. After about 3 minutes, during a period known as Big Bang nucleosynthesis, the temperature decreased sufficiently for these protons and neutrons to fuse into light nuclei, primarily helium, along with trace amounts of deuterium, lithium, and beryllium. Remarkably, about 75% of the ordinary matter in the universe came to be in the form of hydrogen, while roughly 25% became helium. This process set the stage for the elements necessary for the formation of stars and planets. As the universe continued to expand and cool, it entered a dark age lasting roughly 380,000 years. During this epoch, the universe was filled with a dense fog of free electrons and protons, preventing light from traveling freely. Eventually, when the temperature dropped to around 3,000 degrees Kelvin, electrons combined with protons to form neutral hydrogen atoms, allowing photons to travel unimpeded. This release of photons, known as the cosmic microwave background (CMB) radiation, serves as a relic glance at the early universe, still detectable today. Around hundreds of millions of years post-Big Bang, gravity began to play a crucial role in the formation of the first stars and galaxies. Regions of slightly higher density began to collapse under their gravitational pull, aggregating gas and dust. As this matter coalesced, the first stars ignited through the process of nuclear fusion in their cores. These primordial stars were massive and burned hot and bright, creating heavier elements such as carbon, nitrogen, and oxygen through stellar nucleosynthesis. These stars lived relatively short lives before ending in spectacular supernova explosions, dispersing their enriched materials throughout the universe. This stellar debris provided the building blocks for the next generation of stars and planets, leading to the formation of complex structures. After several billion years of cosmic evolution, these processes led to the birth of our own sun, approximately 4.6 billion years ago, and the surrounding solar system, including Earth. Earth formed from the accretion of dust and gas in a protoplanetary disk surrounding the nascent sun. Initially, the planet was a hostile place, plagued by volcanic activity and bombarded by remaining debris from the solar system's formation. However, it was during this tumultuous period that the essential ingredients for life began to coalesce. Water vapor, along with essential minerals and organic compounds, gradually accumulated on the surface, promoting a more stable environment. Around 4 billion years ago, the first signs of life appeared on Earth. Microbial life, primarily in the form of single-celled organisms like prokaryotes, emerged in the oceans. These primitive life forms were anaerobic, thriving without oxygen. The earliest evidence of life, stromatolites, layered structures formed by the activity of cyanobacteria, can be dated back to around 3.5 billion years ago. As time progressed, cyanobacteria initiated a significant revolution known as the Great Oxidation Event around 2.4 billion years ago. Through photosynthesis, they produced oxygen as a byproduct, drastically altering Earth's atmosphere and paving the way for aerobic organisms. This shift not only transformed Earth's environment, but also led to the eventual evolution of more complex forms of life. Over billions of years, life diversified into a rich tapestry of organisms, culminating in the Cambrian explosion around 541 million years ago. This event marked a rapid diversification of life in oceans, introducing the ancestors of all modern animal phyla. With the emergence of plants on land approximately 470 million years ago, life began to thrive in terrestrial environments. The remarkable journey from the violent aftermath of the Big Bang to the intricate web of life on Earth illustrates the profound processes that shaped our universe. Each step, from the formation of stars to the birth of microbial life, underscores a narrative of transformation, resilience, and interconnectedness, a story that continues to unfold.